Alright, page 180 in your textbooks. You had numbers 1 through 6 in the review section for homework last night. Had nothing whatsoever to do with what we talked about yesterday. Just a little bit of review on solving rational equations and a couple of absolute value equations. So I'm going to take a look and see how we did on those 6 problems. That looks dangerous. Alright. Nickname is Spike. Gangsta name.
That's a good dog name.
Yeah, you picture this bulldog, right? You know, but no, Chihuahua named Spike.
No,
Anyway.
Chihuahua named Priscilla.
Alright, number 1, what do we want to multiply everything by to knock out those fractions? Kendall?
4.
A 4. We multiply everything by 4, what does our equation become?
12 cubed.
Well, the 4 and 2 cancel, remember.
Yeah. 2 and then 6 cubed. And then plus 28. And then equals 5 cubed.
Alright, did you not do that in your homework? You did. What did you do in your homework? Don't tell me you kept the fractions.
Yeah.
See, my indoctrination has failed. You're supposed to hate fractions in equations and get rid of fractions from equations, like I tried to Uncle Brandon a moment ago.
In our defense, we did just get through a section where you told us fractions are good. So
That's only in linear equations. Does this have a y and x and
you taught us about linear equations right before you gave us this.
no mental flexibility. That's a crying shame.
For sure.
All right, so finish it out now, Kendall.
You're done.
Subtract the 5 cubed.
All right,
So I get 1 cubed.
and at the same time,
Move the 28 as a negative.
we're done. How many got that answer anyway? Just it was a lot harder than that. Did that look a lot easier?
I did that.
Mine was pretty easy
I was
too.
smart. I did that.
You did that. Well, good
I did
job.
that.
Good job, Abby. Abs. All right, number 2. What do we need to multiply everything by, Genesis?
Number 2, everything by 20.
All right, that'll give us what?
5x plus 8x equals 260.
You must have done it correctly.
Yes.
That or you're really good at your mental math. I wasn't sure which. All right, we combine like terms.
13x equals 260.
And we divide away the 13. You got x equals
20.
20. So it happens to equal its own LCD. How many got x equals 20 regardless of how you solved it? Questions on that one? All right, on the next one. This is a special rational equation because it is a single fraction, equal to a single fraction. We call this, Brandon, a, and to solve a proportion we should. Hopefully all of you cross multiply. Brandon, what did you get when you cross multiply?
4x minus 8 equals 3x minus 1.
And you got rid of the...
So move the 3x over and move the negative 8 over. And then x equals negative 4.
And we got that answer for number 3. All right, good. Number 4, we hear, hopefully all of you finally multiplied by the LCD if you hadn't before, because by now surely you recognized you had to. But we got polynomial denominators. And I said anytime we got a polynomial denominator, you either need to class...
Multiply everything by it.
Well, yeah, anytime it's fractions, but if the denominators are polynomials, you either have to factor or group. And so you should have grouped, and then here should have factored into what, Maddie? And then when you multiply by the LCD, it's a little easier to see that LCD, Audrey.
X minus 1, x plus 1.
Right. And so you multiply this by everything. Obviously, here it's going to cancel away the x minus 1, leave you with an x plus 1. Here, cancel the x plus 1, but leaves you with an x minus 1. Here, everything's canceled. What does our equation look like now, Abby?
3x plus 3 minus 4x plus 4 equals 18.
Good. And if you're checking your work, make sure you caught the positive here. That'd be an easy thing to forget. The negative, getting the positive. Good job there. We'll combine our like terms to get, Michael?
Negative x minus 11 over 7. Sorry, I was reading from the book. Negative x plus 7 equals 18.
Good. And then to finish solving it, a couple of things we could do. What'd you do?
Me?
Yeah.
Oh, okay. I didn't do this, but you move the 7 over,
Okay.
and you get like 11.
We do. And then just
Move the negative.
change the signs. And we get negative 11. How many had? Negative 11 for number 4. Question. Uh-oh, all the girls got it. Michael and Brandon.
I would have if I did the last step,
Yeah.
but I got confused and I got negative x minus 11 over x plus 1 x minus 1.
Yeah, we're not talking about it. Yeah.
You never cleared the fractions
I
out.
never
Neither
did.
did I.
Failures. All right.
Wait,
But to be fair, the reason we throw an assignment at you that we haven't looked at in a while, just keep it fresh. You know, we've got a final exam coming in a few months, so just keep all these little things fresh, little bits at a time. You know, we don't like to think about it. It really doesn't need to be a major thought in our brains, but it is there, right? We need to be able to remember all of these things. So I do like that the book provides these review sections where, man, it's been a while, but it gives you an opportunity to see, do I still remember this? Maybe we don't. All right, do we remember it now? Whether or not we did it correctly in the homework or did it the best way in the homework, does it make sense now? We remember it now that we've seen it. All right, let's take a look at some absolute value equations because it's been a little while since we've done those also. Of course, we know the key to absolute value class is, I think I heard it.
Isolate.
Well, yeah, isolate, but then the real key, positive, negative. There we go. Set it equal to positive, negative, or if it's an inequality, you know, either in between or outside, whatever. Positive, negative is the key. So number 5, we have the x squared positive 2x. Absolute value is equal to 3x plus 6. We're going to turn this into 2 separate equations, Brandon.
X squared plus 2x equals 3x plus 6. And x squared plus 2x equals negative 3x minus 6.
There we go. And then notice we just have a couple of little quadratics, complete quadratics, where we want to set the equations class equal to 0. So that means bringing the 3x over to get a negative x, bring the 6 over to get a negative 6 equal to 0. Here, bring it over to give you a 5x when you add it, give you a positive 6. And now that we've set our equations equal to 0, Kendall,
You can backwards forward.
yeah, we're going to backwards forward, factor that up, each of them, and it should end up with an x plus 2x plus 3. Here, end up with an x plus 2x minus 3. So we end up with, well, I guess the x plus 2 is kind of a duplicate, but 3 possible x values. What are my possible answers for x going to be here? Audrey?
Negative 2 and 3. And then negative 2 and 3. Negative 3.
There we go. So negative 2 repeats again. We don't have to write it a second time. And then negative 3. And remember, the key is you got to check all of your answers and see if they actually work, because sometimes they don't. And so we try plugging in, for instance, a negative 2 to your class. Square that to get 4. And then 2 times negative 2, negative 4. 4 plus negative 4, 0. Absolute value of 0. 0. Plug in negative 2 times 3. Negative 6 plus 6, 0. Okay, so that one checks. Now let's try the 3. 3 squared. 2 times 3. 9 plus 6. Absolute value of 15. 3 times 3. Plus 6. All right, that one checks. So try the negative 3. Negative 3 squared. 2 times negative 3. 9, negative 6. Absolute value of 3. 3 times negative 3. Negative 9 plus 6. Oh, that one's the extraneous root. And so we'll just discount that. How many got both answers working? How many included all 3 because you forgot to check? How many didn't get those 3 answers and have questions? How many didn't get those 3 answers but you understand it now? Questions?
Are the guys the only ones that got that one right?
Maybe so. I wasn't paying that close attention this time.
How much should you read it?
We were showing hands again. No, we'll spare the ladies a disgrace. All right, let's take a look at the next one where we had a y squared positive 6y, absolute right, is equal to a 3y plus 18 Genesis. Let's make 2 equations out of this.
Y squared plus 6y equals negative 3y negative 18. And y squared plus 6y equals 3y plus 18.
All right, again, quadratics, again, set them equal to 0. What do they become when we set these equal to 0, Genesis?
Y squared plus 9y minus 18 plus 18.
All right, and then over here,
Y squared minus 3y.
well, we're going to subtract the 3 over, but it gives us a positive 3y, right? Because keep this out of the greater.
Minus 18.
Minus 18. Then we'll backwards FOIL. What are these backwards FOIL into, Maddie?
Y plus 6, y plus 4. And y plus 6, y negative 2.
All right, so my possible values for y end up being what here, Abby?
Positive negative 3. Oh, wait. Yeah, positive negative 3, and then
Here's the negative 3, here's the positive 3, and
negative 6.
negative 6 as well. Alright, and we check our answers, and of course we square the negative 6 class. 6 times negative 6, 36 and negative 36, 0 opposite side 0, 0, 3 times negative 6, negative 18 plus 18, that one checks, let's try the negative 3. Square the negative 3, 9, negative 3 times 6, negative 18, 9, negative 18, negative 9, but the absolute value of negative 9 is 9, 3 times negative 3, negative 9 plus 18, still 9, that one for a moment there I thought wouldn't check, but it did. 3 squared, 3 times 6, 9 plus 18, 27, you're right. The one who started to say it. 3 times 3 plus 18, and we just said that one. And this time, no extraneous roots, they all check out. How many got all 3 working roots this time? Which means if you forgot to check, lucky you, you could have gotten away with it. Questions? And Kendall's like, yeah, I got away with it. All right, questions on this? Any questions on the homework? All right, well, let's review what we were talking about yesterday. And we've talked before about literal equations, and truly a linear equation is a literal equation because it has more than one letter. What are the 2 letters in a linear equation class? X and Y, right? And so it is a literal equation, and in a literal equation, we have 2 different types of variables, the dependent and the independent. How do I know which one is which? Audrey?
The dependent variable is before the equal sign.
Good, or another way to say it is by itself, right? The dependent variable is by itself, and then the independent variable is, usually written to the right side of the equal sign, but it's not by itself. And of course, any numbers that are worked into the equation class, we just call those constants. We talked about 2 types of variation yesterday. Obviously, these values vary. The dependent variable varies depending on the independent variables varying, right? And the 2 types of variation we talked about yesterday, show of hands, pretty easy names.
Correct.
And?
I don't know.
You're a soccer player. 2 types of free kicks.
Penalty.
Direct and indirect. Penalty kick's a direct kick. It's just 1-on-1. Anyway, direct and indirect. And the guy's like, of course he's going to raise his hand. He's a soccer guy. No. All right, direct and indirect are the 2 types of variation we talked about. Now, for direct variation, in both cases, again, the dependent depends on the independent. If the dependent is the multiple of the independent, then we have what type of variation class? If the dependent variable is a multiple of the independent, we have direct. If it's the multiple of the reciprocal of the independent variable, now we have indirect. Make sense?
Is it also called inverse?
Indirect, inverse, yeah. Indirect or inverse variation, either way. Actually, I think inverse is more the technical term, isn't it? It's the one I gave you in your notes, yeah.
Technical.
I probably was thinking soccer. I wrote direct and indirect in my notes. I'm like, actually, no, she says inverse. I'm pretty sure I'm supposed to say inverse. Let's erase that from YouTube. No, we'll leave it up. The inverse, I guess my brain was thinking soccer. See, and now I got on to you about being a soccer guy, not thinking inverse isn't in soccer. Of course you didn't think of it. All right. Direct and inverse variation. Yeah, good call. I was like, yeah. Anyway, inverse variation. So, the forms for these. What does the equation form look like for direct variation, volunteer? Brandon?
Y equals kx.
Good. The dependent variable is a multiple of the independent variable, meaning independent variable times something. What do we call this k? We use the letter k, but it really just represents some number, some specific number. What do we call that value, Abby?
The constant of variation.
The constant of variation. Make sure you've got that in your notes. Now for inverse variation, remember we said the dependent variable is a multiple of the reciprocal of the independent variable. What does that equation look like? I actually give you 2 forms, but what's the initial form look like? Somebody besides this row. Audrey?
xy equals k.
Good, that's the form that I told you is the easy one to use. You remember the initial form that actually states the definition? We'll go back to Brandon.
Y equals kx. I over x.
There you go, y equals k over x. But I told you, this is really a pain to try to figure out. So I like the form better that you gave me, which is xy equals k. So remember, technically, yes, by definition, inverse variation is characterized by dependent variable is the multiple of the reciprocal of the independent variable. Practically speaking, though, multiply the two variables, you're always going to get the same thing. Okay, that's another easier way, perhaps, to think of inverse variation. Look back at page 173 with me. I want to kind of recap what we did at the end of the hour yesterday, since we didn't get to fully develop it anyway. Remember, as we look at the top of the page, we had some tables of values here. And on numbers 1 through 4, there was constant, there was direct variation, rather. So you take the x, multiply by something, you're going to get the y. In the first box, pretty easy. You multiply everything in the x by 6 to get the y. So 6 is your constant variation. We could say y equals 6x. For number 2, a little bit more challenging, but still not too bad. What do we multiply the x by to get the y? We said negative 3 would give you your y. So y equals negative 3x. Again, do you see that layout? Y equals 6x. Y equals negative 3x. Whatever that constant is. Number 3 was kind of a weird one. But if you looked at the odd numbers, it was a little bit easier. What did we multiply x by to get y? 1/4. So we would say that y equals a fourth x. And then number 4 was kind of obnoxious. We had negative 1/3. So y equals negative 1/3 x. Then we dropped down to 9 through 12, and these were all inverse variation. You didn't multiply by anything specific. You had to multiply by a reciprocal of something. And so I said the easiest way to look at this is, what do you get when you multiply the numbers together? On number 9, doesn't matter which xy pair you pick, you always get a 1. On number 9, when you multiply the xy's together, you always get 4. So that was your constant of variation. We could say xy equals 4, or to put it in the form that's more standard, again, this is my cheater way to do it, just get the y by itself. Y equals 4 over x. In the next one, number 10, what was that constant of variation? You multiply, you always get negative 10. So y equals, or xy equals negative 10, but get the y by itself, y equals negative 10 over x. Number 11, the constant was negative 2. You multiply those numbers, you'll always get a negative 2. Number 12, it was 1, because you were literally multiplying reciprocals by each other. We also looked at numbers 5 and 6 already. I just want to go back to number 6. Remember, it said that W and R were directly related. So that means I can either say W equals KR or R equals KW. Really doesn't matter which way you go with it. Let's just say we went with R equals KW. Well, you have to know the K to do anything, right? You have to know what that constant of variation was. So it said, well, we could plug in the numbers they give us. They tell us R is 8 and W is 4. Well, based on that, what does K have to equal, class? 2. Now, I think when we looked at it in class, we looked at it from this perspective, K was a half. Well, obviously, if we look at it from the other perspective, you're going to get the reciprocal value, but K was equal to 2 if we solve it with this form. We're going to get the same answer in the end anyway. So we can say R equals 2W. And so it says if W is 32, what's R? In class, we would get 64. That's actually the number we got yesterday as well when we worked it the other direction. Drop down to number 13, though, because we haven't done anything with the inverse variation. Number 13. Go ahead and read that problem for us, if you would, Genesis.
Let A and B be inversely related such that B equals 18 when A equals 3, find B when A equals 2.
All right, so for inverse variation, again, this is technically the form they want, but I cheat, and I go with the form that Audrey gave me. So if it says that A and B are inversely related, I'm going to say AB equals K. And it says they're inversely related such that when B is 18, A is 3. You see, all I do is I set up my form. Instead of X and Y, I plug in the letters they give me, plug in the numbers that they give me, and I find K. You can use a calculator if you need to. What's K, class? 54. All right, so if K is 54, then that means my equation is more specifically, yes, it's in the form AB equals K, but if K is 54, it's AB equals 54. So far, so good. Then we look at the last piece of information. It says, find B if A is 2. All right, go ahead and plug the 2 in for the A. I already know the K is 54. We find B. Class, what is B? 27. Notice, as the A got smaller, the B had to get bigger to compensate. They're inversely related. Does that make sense? There's inverse variation there. Look at number 14. Go and read that one for us if you would, Maddie. All right. I picked the wrong person for this one. As soon as you started reading, I was like, probably should have picked like Michael for this one or something. Oh well. So, how should I set up my initial equation since it tells me that M and S are inversely related? I'm sorry? MS equals K, or MS, SM, whatever you want to do. MS equals K. And then I'll plug in the numbers they give me up front. 4 times 15, and we can tell that the K must equal 60, what he said, yeah. Hush. All right, and so my equation now is more specific. This just shows an inverse relationship. If I plug in the K, I know the specific inverse relationship is MS equals 60. Then it says, find when M is 10. And what do we get for S? 6. Notice the M got considerably larger from 4 to 10. The S dropped quite a bit from 15 to 6. You see that inverse variation. Seem pretty easy setting this up? Now, the problem is there are a lot of word problems where they won't come out and specify it quite this way. They'll give you more vague terms, and you're going to have to deduce the relationships in some cases. Look at number 7. Read that for us, Kendall.
The force applied to a wrench is directly related to the force of the wrench. The support of the wrench is 9 F. When the force of the wrench is 27, find the torque of the wrench when the force of the wrench is 18.
And that N stands for newtons, by the way. I don't know if you remember that from physical science. It's been a little while. All right, so it says that force and torque are directly related. Okay, so Kendall, what equation could I set up?
Y equals kx.
Well, initially y equals kx, but instead of x and y, I'm going to use the letters they give us. They give us force as F. And by the way, that little T-looking thing, that's the Greek letter tau. We use that in physics to represent torque. So I could say that F equals K tau, or tau equals Kf. And I'm going to let Kendall pick. Do you want the first version or the second version?
First one.
The first one. So we'll go with F equals K tau. All right, so we're going to take the numbers that they give us here. It says the torque of a wrench is 9 Newton meters when the force on the wrench is 27 newtons. So let's plug those numbers in. Tell me what this looks like now.
27 equals K.
All right, and now to solve for K, K simply equals 3. All right, so then instead of F equals K tau, I can make this more specific because I now know what K is.
F equals 3 tau.
There we go, F equals 3 tau. Do you see, we're doing the same thing, but instead of just random letters, they put some words to it. Make sense? All right, then it says, find the torque of the wrench if the force is 18 newtons. So now I'm going to use my completed equation, and it says if the force is 18 newtons, what's the torque? And you might be able to, probably all of us can do this in our heads. Class? 6. 18 is 3 times what? Well, 18 is 3 times 6. So that means the torque must be 6. Now, look at the problem. What were the units they gave us for torque earlier in the problem? Newtons times meters. So that's the units we're going to use in our answer. I don't expect you to memorize all these crazy units and stuff from science. That's not why we're here. You'll learn that in physics when you get to your senior year, or physical science. You might have learned that earlier in the year, right? The Newton meter. But you don't even have to remember it. You just have to look back in the problem and see what unit they used. Does that make sense? All right, let's take a look at number 8. Read this one for us, if you would, Abby.
The weight of an object is directly related to the mass of the object. If the weight of an object is 49 newtons when the mass of the object is 5 kilograms, what is the weight of the object when the mass is 7 kilograms?
How should I set up my initial equation here, Abby?
Sorry, y equals kx,
Well, yeah, but again, we're not going to use x and y. We're going to use the letters they gave us.
w and n,
So
w equals kn,
w equals kn. All right, now we're going to substitute the numbers they initially give us.
49 for w and 5 for the n.
All right, and then at your seats, using your calculator probably, let's solve for the k.
9 4/5.
Oh, I hate fractions. 9.8. You could say 9 4/5. I mean, that's not wrong, but 9.8 is easier, I think, because it's just faster to enter. Like, it's 9.8 on the calculator instead of 9 and 4 fraction 5. And, see, I'm all about keystrokes. Fewer is better. I'm lazy. All right, so, Abby, we now can get our equation more specific. Still with me, Genesis? Okay, we can get our equation more specifically as
W equals 9.8n.
good. Again, we don't want to leave it with a k. K tells us nothing. We need to know what the k is so we can plug it in. So that's the whole first step, is figure out, well, set up the basic layout, the form, right? But then figure out the k so you can actually replace it with a number. Now we can solve the second half of the problem. It says,
What is the weight of the object when the mass is 7 kilograms?
so pretty straightforward. In for the m, we plug in
7.
7. And we multiply, and we get the weight. And what do we get for the weight?
68.6.
And what are we going to use for weight? What unit? Newtons, that n thing, right? It says the weight of the object is 49 newtons. You know the beauty of it is you don't even have to know that it means newtons. You just say, well, they put an n last time, I'll put an n this time. All right, it's a great letter. All right, questions on this? Questions on this? Let's drop down to the bottom now, look at some inverse variations. Number 15, I like this one. Genesis, read this one.
As the temperature outside goes down, the sales of hot chocolate go up. If a diner can sell 10 cups of hot chocolate, when the temperature is 20 degrees Fahrenheit, how many cups can be sold when the temperature decreases to 8 degrees Fahrenheit?
There we go. Now, it doesn't come right out and say there's an inverse variation. Did you see that? It never said, or really, no, I didn't see it, right, because it's not there, right? It never said they're inversely related. How do we know there's an inverse relationship, Genesis? It doesn't use that word, but it does tell us it's inverse. How? What phrase tells us it's inverse?
Temperature decreases.
Someone help?
It goes down and goes up.
Right, the one goes down, the other goes up. So since they're going in opposite directions, it can't be direct. It's got to be inverse. Does that make sense? All right, so they didn't give you letters this time, right? The last time they gave us F and tau and W and M. You get to make up your own letters. What are the two things we're talking about in this problem, Genesis?
The temperature and hot chocolate.
Temperature and hot cocoa, right? So, what do you want to use for your letters for temperature and hot cocoa? T and H, all right? And since they are inversely related, what's my basic form for inverse relationship? Inverse variation.
Y equals K.
That's direct. What about inverse? What's the form?
Y equals
Upper class?
K
K over X, but I said I don't like that. Yeah, that's a sad face. Okay, with tears. All right, so what's the form I like better? Do you remember now, Genesis?
X, Y, K.
Good, X, Y equals K. But again, instead of X and Y, we're using your letters, and you said H and T equals K, correct? All right, so let's take the upfront numbers they give us. They said that when the temperature was 20 degrees, they sold 10 cups of hot cocoa. All right, so what's the K? What's the constant of variation? You can use your calculator. 200, yeah, you didn't really need a calculator, did you? All right, so, again, we're going to take our starting equation. We just got the form, but we're going to actually replace the K that helps no one with an actual number that we now found. So our new form is
2
Helper class? Good, HT equals 200. Again, we don't really want the K. We have to start with K, but we don't want to keep the K there. We want to figure out what that K number is. That's the key to solving the rest of the work. So we can replace the K with the 200 we just found. Okay, HT equals 200. Now then, they want to know, how many cups of hot cocoa do you sell when the temperature is 8 degrees? At your seats, how many cups of hot cocoa? 25. So temperature goes down, hot cocoa sales go up. Sounds like something for senior snack cart. Questions on number 15? All right, go ahead and read number 16 if you would now. Michael.
Water has been draining out of a tank for 10 minutes and has 18 cubic feet of water left in it. Use inverse variation to determine how much time it will take to have only 3 cubic feet of water left.
Again, they didn't give us letters here, but they did come right out and tell us there's inverse variation. So we're going to use what basic form here, Michael?
Xy equals K.
Xy equals K, but instead of X and Y, we get to pick letters to talk about what two things?
Time and water.
Time and water. Okay, so we can say
T and W.
TW equals K. And they say after a certain amount of time,
10 minutes.
10 minutes of drain time, right? That's 10 minutes of draining. There's how much water?
18 feet.
All right, 18 cubic feet. So what is the K?
180.
180. All right, that means my equation specifically is
T plus W equals
T plus W.
W equals K.
Well, yeah, K, but we
Yeah.
know what K is. We don't have to leave the K. We don't want the K. There we go. So we don't really want K. We're just kind of stuck with it until we figure out what it is. Kind of like the Colts and Carson Wentz. And well, anyway, all right. Patriot fan, don't laugh. All right, we beat you. Remember? Anyway, so we didn't make the playoffs, but we beat the Patriots. That's all that matters. We lost to Tom Brady again, but we beat the Patriots at least. All right. All right. Anyway, so the end of it says, how much time is it going to take to have only 3 cubic feet of water? So we're going to put 3 in for the W, and we're going to solve for the T. Again, we might be able to do this in our head, class.
60.
So that means it's going to have to drain for 60 minutes before we'll have the 3 cubic feet of water left. Does this make sense? Now that we've had a chance to see a lot of these, we get the feel for how to use direct and inverse variation. How many feel like you got it? How many feel like, I'm scared? All right, so you got it and you're scared. All right, well, let's practice a little more. Then page 180. Back to page 180. I want you to do 9 through 12 in the review section, but I want you to try them on your own now. Page 180, 9 through 12. Try these on your own and let's see how we do. Again, you're either starting with xy equals k or y equals kx, depending whether it's inverse or direct variation. got them? May sit there with a smug look on your face. It's a good smug look. Practice it a lot.
Yeah.
Imagine with the younger siblings you have to practice that look a lot, don't you?
Mm-hmm.
I don't think she's listening. Okay.
I just don't care.
Ouch.
I've used it long enough.
She's immune.
Yeah.
Okay.
She tolerates it too well.
That's been fine.
No, I just don't care.
Brandon's finished. Abby's finished. Each of them also sit there with smug looks. You got about 45 seconds longer to finish. Let's go and take a look. Pencils down, even if you're not finished with all of them. Let's see how we did. Number 9 says the length and width of a rectangle are directly related. So what's the basic form we're using, Kendall?
Y equals K X.
But I'm going to replace y and x with what letters?
L W.
So I'm going to say L equals KW. It tells me that the length is 9 feet when the width is 4 feet. So to solve for the k, I'll divide away the 4, quickly and easily get k is 9/4. That's great news, because that means k can be gone, like Carson Wentz. And we can replace with a much more competent and capable 9/4. Anyway, once we've got our equation in final form, right, this is the equation we wanted all along. Now we can solve what it asks for at the end. Find the length if the width is 10 feet. And so we multiply the 9/4 by the 10. What did you get for that length, Kendall?
I left it as a decimal.
That's okay.
Okay, I got 22.5.
You have 22.5 feet. You could say 22.5 feet. Either of those answers would work. In feet, you don't really want to say 45 halves. 45, like how long is this room? 45 halves feet. This is weird, right? 22.5 or 22.5. How many have that answer? On number 9. Questions on number 9?
I just multiplied the 9
Oh, that's sad.
So you went inverse variation instead of direct,
Yeah.
basically. All right, does it make sense now since it says directly related, not xy equals k, y equals kx?
I had that, but instead of dividing the 4.
Oh, you did have it. You
Yeah.
just still came up with a k equals 36.
Yeah.
That's sadness. All right, let's take a look at number 10. Certain printing company has a direct relationship between cost and number of pages per book printed. So we've got two things, cost and pages, directly related. What's the equation, Maddie? When P equals KC. Pages equal the constant times the cost. All right, so we'll plug in the numbers. It says there's 100 pages, and the cost is 10 cents. I'm assuming that's per page. All right, what did you get for your constant value? 1,000. So really my equation is that P equals KC, P equals 1,000 C. All right, then it says find the cost of a book that has 550 pages. It can't be cost per page, it must just be the cost to print the book. Okay, so 550 pages, we're going to plug the 550 in for the P, and 550 equals 1,000 C. Divide away the 1,000, what do you get for the cost? 55 cents to print this book. How many had 55 cents for number 10? Questions on that? Again, start with the direct form in both cases, but instead of y and x, replace with the variables they give you. Plug the numbers in, solve for your k. Once you know your k, replace it with the actual number. And then plug in the extra number they give you to find the missing number. Number 11 changes gears here. We've got an electronics store manager. It says as he lowers the price of his computers, the fewer computers the store has. Presumably they're being sold. Hopefully not stolen. All right, the lower the price, we don't have as many in stock. That's happy. You don't want the computers in stock, you want them sold because then you have more money. So if he says if he lowers the prices by $100, the store has 50 computers. So find out how many computers the store should have if he decreases their prices by $200. Since it's lower prices, fewer computers, he lowers the prices by more. Okay, so not the price itself, not lower price, but the amount he lowers the prices is related to the number of computers left. So this one's kind of tricky. It's an inverse relationship here. A bigger sale equals fewer computers left in stock or in inventory. Does that make sense? Now, if you went direct relationship here, I actually totally understand. But we should go inverse. What's our basic form for inverse here, Genesis? And so we're going to say his price drop, or his sale. I'm going to go with S for sale. The sale times his inventory is constant, or SIC. All right, so we go with sale times inventory is constant. Well, if he puts a sale of Genesis $100, his inventory drops to 50 computers. All right, so what is the constant here? Michael?
5,000.
5,000. So that means instead of SI equals K, which we didn't want to be SIC, we'll say...
where are we? I'm confused because I did different symbols. I did PC because price and then computer, and then it got PC. So like...
okay, well anyway, let's roll with my letters and do the same thing you did. We just found K, so plug it in.
Oh, yeah, SI equals 5,000.
There we go, SI equals 5,000. The beauty of it, you can pick whatever letters you want unless they specify. All right, so now it says he puts the sale as a $200 sale. So if we have a $200 sale, let's see how much he has left in his inventory. So we plug the 200 in for the S, we divide, we get what is left in his inventory, class?
25.
25. And 25 computers is the answer. I already got that answer. All right, how many thought it was direct? Because it kind of sounded direct, so I could see why you might have done that. The next one is a little bit more straightforward. It clearly points out an inverse, right? It says the business executive knows that as he increases requirements for a position, fewer applicants he'll have. So the executive adds 3 new requirements, applications drop to 5. How many applications will he have if he increases the job requirements to 5? All right? So clearly going with inverse, so again, starting with the XY equals K, but the two things we're talking about in this problem, Audrey, are...
requirements and applications.
All right, so what could be our equation?
RA equals K.
RA equals K. And it says he adds 3 requirements. He has only 5 applicants. So K is 15. So really, our equation is...
RA equals 15.
I was really hoping you were going to go with AR, because then I can make a comment about ARC and then AR 15. But you went RA, so I figured I'd say it anyway. But anyway, RA equals 15. So then he says, well, now let's suppose he increases the requirements of his job listing to 5 different requirements. How many applicants can he expect? Now, class? I heard it. 3. All right, how many had that for number 12? All right, now that you've had a chance to try it on your own, even if you didn't get them right, having gone over them now, do we feel like we understand direct and inverse relationship a little bit better? Questions on it? All right, I'll tell you what, we'll stop there. For homework this evening, here's you to read over pages 174 to 176. You'll have to read because you ain't going to get the homework unless you do. All right, page 174 to 176. If you do the reading, though, including the example problems that you read over, you should be just fine on the homework. Homework is to do page 179, 1 to 15, the odd. Page 179, numbers 1 through 15, the odd. We're changing gears just a little bit here. Building on what we talked about with variation, going into the rule of functions starting tomorrow. So page 179, 1 to 15, the odd, after you read pages 174 to 176. We'll take a look at all of that tomorrow. Have a wonderful rest of your day. When the bell rings, you will be dismissed.